So till now we have seen two methods to solve this question. Now let's see the third method to solve this question. The third method is going to be Brent's algorithm, which is basically a similar method like Floyd's algorithm, but it has a better performance, not in terms of complexity, but in terms of actual performance. And there's also a special point with Brent's algorithm that works here. Okay, so let's see what it is. So basically, first thing that I should mention is that we don't actually need uh, Brent's algorithm for specifically this question, because this question only demands us that we have to detect if there is a cycle or not. Okay, Brent's algorithm also gave us the entry point of the cycle. Okay, so let's see how this algorithm works. First thing, we'll need two pointers. Okay, one is going to be a checkpoint and another is going to be a runner. Okay, so what the checkpoint is going to do is it's going to store, okay, so this is my current status where I'm standing, and runner is going to be only pointer that is going to traverse. Okay, with some certain rules. Okay, so second step, if these two pointers meet each other, then we have a cycle with this. Okay, so this checkpoint is going to stay at one place, and this runner is going to move this whole loop, and it's going to meet with this checkpoint again at the entry point of the loop or the cycle. Okay, else after each 2 of n 2 to the power n moves, we have to shift the checkpoint, and hence it's going to be an exponential search. Okay, so basically this is a part of algorithm where the Brent's algorithm says that after each 2 raised to the power n moves, we are going to increase the power, and we are going to move the checkpoint to the runner. Okay, so you can see, let's see from the first case. Okay, so initially we have to start it with 1, not 0, because if we start it with 0 we cannot multiply it with 2. Okay, so we'll start it with 1, and you can see my runner has already moved 1 point. Okay, or 1 node. Okay, so the current length that my or the current distance that my runner has traversed is 1. Okay, checkpoint was here. My runner started from head and moved till this second node. Okay, so you can see the length that it has traveled is 1 and the power is 1. So this means that we have a case where length is equals power. In that case, we have to do increase the power by 2, then we are going to move our checkpoint, and then we are going to move runner and increase length. Okay, this move runner and increase length is going to take place for each and every node that we are going to encounter with runner. Okay, so for each traversal, it's going to increase length, which is storing how much distance that our runner has covered, and this this runner is basically only a pointer that is moving. Checkpoint is just storing till which 2 raised to power n or which exponential power we have traveled. Okay, so now for the second case, you can see that checkpoint is at 2. The runner has increased to second node. The current length is going to be 1 and power is going to be 2. Okay, for the next iteration, now runner has reached to 2. So now the current length that runner has traveled is 2, power is also 2, hence we have the same case again where length is equals power. In that case, we are going to update this checkpoint to our runner. Okay, and we are going to move runner to the next node. Okay, in that case we have a loop, hence we reached to 2 again. Okay, in this case we have length again equal to 1 because from 4 it traveled to 1, so length equal to 1, and power is 4 now because we have doubled our power. Okay, so basically by doubling our power, we are increasing the space with which we can travel. Okay, so initially we can only move to one node. In another round we are going to move to two nodes. In another round we are going to move to four nodes. In another round we are going to move 8 round. So exponentially we are increasing how many nodes we can travel using runner at once. Okay, so now checkpoint is at 4, runner is at 1. Okay, this first traverses, so it's at runner is at 2. Next iteration, the length is equal to 2, runner reaches 3. For the next iteration, the length is equal to 3. Okay, so length here should be 3 and power is equal to 4. So we have reached a point where checkpoint equals runner. So you can see this is the point where cycle starts. Okay, so this is the benefit of you can say Brent's algorithm. Okay, so let's code this one. So first let's make a safe case where if not head, okay, if we get an empty head, we're going to return null, or you can return false because there's no list, so there cannot be a cycle. Uh, Next, we'll need four things. First, we'll need a list node star checkpoint is equal to head, list node star runner equal to head, or you can start it with head. Okay. Next, we'll need int power is equal to 1 and int length, which is right now is going to be 0 because our runner is at same location as checkpoint. Okay, or better you can do is, rather than doing this, you're going to put length to 1 and this add heads next. Why we are doing this is because you can see here that if we started both of them with head, so in the initial case itself, we'll hit a case where checkpoint is equal runner, and hence our algorithm will always going to return head to us. Okay, so to kickstart this algorithm, we'll need this type of case scenario. Okay, so length is going to be 1, power is going to 1, runner is going to be heads next. Next, while runner is not equal to null. Now we have first case where meet each other. So runner reaches checkpoint. So if runner equal checkpoint, in that case we can return true. This means we have a cycle with us. Second case, this time we are increasing window. So exponential window. So in that case, to check if we need an exponential window now is if power equals length. In that case, we have to increase our window. So to increase window, we'll do power is equal to power star 2. So we are multiplying power with 2. Okay. Second, we'll reset the length to 0. Third thing, we'll move our checkpoint. So checkpoint is equal to runner. Okay. And in the end, we'll have this case where in the end, this is the base where for each node, runner is equal to runners next. So runner is going to move for next each and every element, and length plus plus. Okay, so length is increasing because we are moving for each and every next node, and we have this to move a runner. Okay, and in the end we have to return false because if we exited the loop, runner reaches null. That means there's no loop in our linked list. Okay, so that should do it. Let's run this. So the step is to increase power. Okay, we have this issue. Run. Let's run this. Okay, let's submit this. So we have discussed pretty much the one of the best algorithms in linked list, the Brent's algorithm. It's also going to be used in detection of what is the entry point of the cycle of this cycle in this linked list. Okay, So that's it for video. Thank you.